Welcome to the Gatan Microscopy Software Analysis Tools webinar series. Our speaker today is Dr. Ben Miller. He joined Gatan in 2016 from Peter Crozier's research group at Arizona State University and has a background in catalysis research as well as in situ transmission electron microscopy. Ben's responsibilities at Gatan as an in situ application specialist include testing new products during development, demonstrating to and training on Gatan products to customers, and developing and promoting better techniques and workflows for in situ electron microscopy. As I now hand it over to Ben, I hope you find the information on Python and GMS useful. We look forward to hearing your questions and your comments.
Yeah, thanks, Stephen. One last thing of introduction. If you have questions during the presentation or you have comments or you want to contact us, you can enter those in the questions pane, which you should see as you see here in blue. And we'll talk more about that later. So I'm really excited to be presenting today about Python in GMS, and as Stephen just mentioned, I'm the in situ applications person at Gatan, and you may have noticed that doesn't really have anything to do with software or coding or scripting or Python. I really have no formal computer science or programming training either. I'm a microscopist by training, a material scientist. But as I'm collecting and processing and analyzing data myself or working with data from collaborators, I often want to do things that really can't be done without scripting. And it's something I enjoy, so I tend to write scripts. And I've had access to the Python scripting in GMS for a while now, before it was officially released. So I've been one of the first people to be able to use this, and I've had a lot of fun writing Python scripts for GMS. And so the first thing I want to say as I start this webinar is a bit about what I hope to accomplish in this webinar and what this webinar is not. So it's not meant to be a tutorial on how to get started using Python in GMS. And it's also not going to be a presentation that describes in depth how Python was used to answer specific scientific questions based on one data set, like I might present at M&M or the European Microscopy Congress. Instead, this presentation is really meant to demonstrate the potential of Python scripting within GMS. And I really hope to inspire many of you to write your own scripts, and also maybe to partner with me or with others within Gatan to collaborate and help us help you to get the most that we all can out of scripting within GMS. So the first bit of my talk is going to be an introduction, and I'm going to talk a bit about what we're doing, how you can use Python in GMS, and why would you want to script within our software. So first of all, what is GMS? This is also known as DigitalMicrograph. Some of you may be more familiar with that term. If you have older cameras or older spectrometers, you might be familiar with something that looks a bit like this. This is our older version of our software, GMS2. And so if you have any newer equipment, then you would have GMS3, which looks more like this. And GMS is Gatan software for data collection, data processing, visualization, and controls all of our hardware as well. So how do you install GMS? You can get a free version, a free offline version of GMS today. What we mean by offline is that it's not connected to any hardware. It's not connected to the microscope. But you can get this for free on our website today. This is just an image of our homepage, and then a QR code as well that you can use to link to that. And right on our homepage today, we have this this advertisement for the free version of our software, which for a limited time, we are offering even additional features in our free software, like EELS analysis, etc. So the next question I want to ask and then answer is, why use scripting? If Gatan already makes software that's designed for electron microscopy, why would you script? Commercial software like GMS can really be great for standard techniques that have been around for a while, but there's a vast spectrum of techniques and applications, and researchers are constantly developing new techniques, new methods. These might be for specific experimental designs, new experiments, or they might be because you want to come to different conclusions from the same old data, doing different types of analyses to arrive at different results. And by their very nature, especially in academic research, researchers are constantly developing these new methods of data collection and processing and analysis. So scripting provides infinite flexibility for that type of work. For developing new things, you can rapidly prototype scripts to do exactly what you want, and you can also easily tweak those scripts as needed, especially if you are fortunate enough to be the one who wrote the script in the first place. Then it's very easy to make changes as needed. So GMS has always had its own scripting language. We typically call this DM scripting, and you can do anything from simple macros to large, sophisticated applications. And some of those you can even purchase online. Companies are selling these applications written based on DM scripting. It has a C++ style, but also some object-oriented programming elements. And even just recently, we've added an improved editor for scripts, and also additional debugging tools, and a lot more documentation. So if you've done DM scripting in the past, but it's been a while, or you haven't checked out the help in GMS for a while, there really is a lot of new stuff for DM scripting within GMS. But of course, now, and the primary subject of this talk is how we're now adding Python to GMS as well. And so GMS 3.4 and higher now have Python scripting capabilities. Python is one of the most popular scripting languages, along with Java and C and C++. And increasingly, Python is being used for scientific computing, exactly the sorts of things that you might want to do for microscopy data. And there are a lot of different packages out there that can enable you to do really sophisticated processing and analyses rather easily, and I'll talk a bit more about that later. And finally, Python can be embedded in applications as a scripting language, and this is what we're doing in GMS3. So why use Python scripting, and why add Python scripting when we already have a scripting language in GMS? I think there are three reasons that come to my mind first, and the first of those is familiarity and popularity. So you are not so likely to know someone who is an expert at DM scripting. Maybe if you're listening to this presentation, that's maybe a bit more likely. But you're quite likely to know someone who knows Python. And also the learning curve, if you don't know Python, it's pretty easy to learn how to write basic Python code. All of the scripts that are in this presentation were either written by me from nothing or modified by me to do what I want them to do. And I've only been using Python for maybe 1.5 to 2 years. Primarily after Gatan started talking about implementing Python, I decided that I should learn how to write Python code. It's fairly easy to learn, and you can utilize a lot of existing code. And I think this is really the primary benefit for using Python scripting, is there's a vast amount of existing code online, most of which is free, most of which is open source. There are a huge number of really mature and sophisticated packages, including those that I've listed here: SciPy, NumPy, Matplotlib, scikit-image, scikit-learn, Pandas, TensorFlow, Keras, PyTorch, and the list could go on and on. The packages that are available for free online. And these can enable you to write really sophisticated code without needing a computer science degree. So the primary question that I want to address in this webinar is this one: why use Python within GMS? Why would that be better than just using GMS to collect the data and then using Python afterwards? And I have a number of reasons that I want to talk about. I'm going to try to organize these reasons around the 5 V's of big data. And because of time, because I have a lot to present today, I'm not going to go into these in detail and explain the 5 V's of big data, but look it up if you're interested. But I do want to explain how each of my reasons for using Python in GMS are related to these, and how and I want to show some examples as well, concrete examples of each of these reasons. So the first one is reducing data import and export and transfer and conversion. And I'll give a couple of very simple examples of that, and then one more practical, complicated example. Then I'll go into a bit of scripted data acquisition with 2 different approaches to scripted data acquisition. One, time-lapse to control the speed with which data is collected, and then another, triggered in situ acquisition, where the number of different signals that are acquired can be enhanced using scripting. And then live processing and visualization at the microscope. I think this is another benefit of having Python within GMS, is doing processing on the fly while data is being collected. This is a really exciting possibility. And then analysis at the microscope, actually getting to a scientific answer or very close to a scientific answer while still sitting at the microscope. And I think this becomes possible as we have advanced processing and analysis techniques that we can run directly within GMS while data is being collected. So the first script example that I want to show is a simple one, and I'm going to go through this actually line by line and show how having Python scripting within GMS is going to enable us to reduce the amount of import and export and data transfer and data conversion. We can very easily get the raw data out of any image or data set that we see in GMS. So the first command that I have here is just to get the front image. So whatever is displayed in front in GMS, I'm going to get that image. Then from that image, I'm going to get a NumPy array. So with just these two commands, now I have a NumPy array that has all the data that's in this image in GMS. So that was really easy. And now I can go on and do whatever type of processing I want to do. So in this particular case, I'm just going to multiply the data by -1, and this will invert the contrast of my image. But really anything is possible here, and we could substitute any sort of processing into this script. Now that I have this modified image data, I'm going to create a new image in DigitalMicrograph in GMS using this command. And then finally, I'm going to show that image in GMS. And so now you can see in the video at the bottom what that looks like. I'm just playing the video over and over again here. And you can see the contrast invert. And very, very simple, very quick. Just a few lines of code, and at the end here we have some cleanup for memory reasons at the moment that we have to do. But this script is very simple and shows how easy it is to extract the raw data and do something with it in GMS in Python. So now my next example is going to be very similar. So I'm going to start and end the script in exactly the same way, but with a slightly different, more advanced processing. So again, I'm going to get the front image and then get a NumPy array from that image. But now this time I'm going to use SciPy, a package that I've downloaded and installed using pip. And I'm going to use a filter, a Gaussian filter specifically, to do a Gaussian blurring of this image. So I have my sigma for this Gaussian blur, and then I have my command here to apply this Gaussian filter to my NumPy array that I've extracted from the image and create a new modified NumPy array. So again, very similar to the first script, but with slightly more complicated processing. And there's a lot going on here in this one command, but I don't need to know really anything about that, to be honest. It's very simple, very easy to apply that Gaussian blur. Now, again, I'm going to create a new image from that modified data and then show that image. And if I run the video here, then there we go. I have my blurred image. And this might be a useful first step for some types of processing. Maybe if I want to reduce the amount of noise in the image before thresholding to determine particle size, or maybe particle tracking, that sort of thing. But a very simple example with just 3 lines of code. And one thing I should point out, for those of you who were already thinking that I should import SciPy first, that's true, and I should definitely put this import command right at the beginning of the script, so that other users of my code will know exactly what packages are required just from reading the first few lines of code. So my next example is going to be even a little bit more complicated. This is the last example where I'll go through line by line. And in this case, I'm going to import a couple of different packages. So first NumPy, and then matplotlib. But to do this, to import matplotlib into Python in GMS, I'm going to need these 2 lines here in the middle. And to be honest, I don't know what these lines do exactly, but they're required for importing matplotlib, so I put those in there. And now I've imported matplotlib and NumPy, and can use commands from those in my script. So in this script, I'm also going to create my own function. So here I'm starting to define my own function called plot drift data, where I take as inputs to my function data and some string for my title. And we'll see where I get those in a minute, but I'm going to create a figure and an axis in that figure, and I'll put a title on there. And then maybe set some axis limits that are defined by my data itself. And then finally, I'll call the plot command to actually create the plot from my data, and then show, which is the very last command that you would always use when using matplotlib. So there's my function for plotting drift data, and now we'll get back to the body of my code, where I'm going to first get the front image again, as in the previous 2 examples. And then this time I'm also going to get the name of my image, because I'll actually use that in the title of my plot. Then I'll get the NumPy array out of my image. And this time, not only will I get the raw data, but I'm also going to scale the data by the intensity scale that's in this GMS image. So now I have my scaled NumPy array, and I will use my plot drift data function with my scale NumPy array and the image name that I got from the image, which will be my title. And so let's see what this looks like. And I could even make this a bit more complicated and add some more axes titles, etc. We'll see that in a minute. So let me pause this for just a second and explain what I'm doing here, because before I run my DM script, this DM script is intended, and I wrote it to plot drift data within GMS. But first, I'm going to generate that drift data by measuring the drift from a real data set. So this is the data set where I was heating and cooling the sample. And so you can see it drift back and forth. Play that again. Drift back and forth as the data is as the sample is heated and cooled. And so I want to measure that drift and remove that drift from the data set for my experiment. But then my Python code is going to take this nice drift plot that we get in GMS and plot it in a slightly different way. So now within GMS, I'm removing that drift And one other thing I want to point out here is that up to this point, I'm only using the tools that are built into GMS. And these are really nice. There's really no reason for me to script drift correction for this data set, because the built-in functionality for GMS is much better than anything that I would be able to script unless I worked on this for months and months. So I was able to use the tools that are built in, and now I have this drift plot. But in the drift plot that's created in GMS, I have two different line plots for the X shift and the Y shift. But what I want, and what my Python script is going to give me, is a 2D plot where I see the sort of the drift vector as a function of time. So if I run that script, that Python script, now I have my 2D plot, and now I'm just switching to my slightly more complicated script where I've added some axes titles, and we can see that also in the Python matplotlib plot, it's interactive. I can easily zoom and pan on this this plot that I've created. So again, a simple, nice little example of how I can very easily access the data that is displayed in GMS. So the next example is one I'm not going to go through line by line. This is an example of a 40 stem data set and non-negative matrix factorization that I'm going to do on this data set. And I want to show this again to emphasize this ability with Python in GMS to really limit the amount of transfer, data conversion, export and import. I don't want to do a lot of moving of my data or converting my data. I want to do as little of that as possible, because some of these STEMX data sets can be very large, easily over 100 gigabytes. So if we can do the processing directly on the Gatan PC, then I don't have to transfer any of that data, and maybe I can very easily transfer the process data instead, which will be much smaller in this case. So this Python script that I have is only 25 lines. This is something that I took the original from the GMS help example scripts, and then modified it slightly to use it for this 40 stem data. And I want to use this to find interpretable components of the data set. So in the top here of this figure, you can see what you might see in GMS if looking at one of these 40 stem data sets. So I have my picker tool here on an area of the image, and that gives me a diffraction pattern. And in that diffraction pattern, I can see the area that I'm using, that I'm summing from that diffraction pattern to produce this image. And that's great. And we can, within GMS, do all sorts of different virtual apertures and much more complicated regions of interest than just this simple square. But as far as I know, we can't yet do non-negative matrix factorization directly from the user interface. So this is something that I need scripting for, and it was quite easy for me to write a Python script to do this in GMS. And so here we see other components that I've generated. So we can see the diffraction pattern component and the fitted map images that are both output by this Python script. And these are output as stacks. and I think I generated 10 components, and I'm displaying 3 of them here. One component that it found really shows the thin region. It's a component that's prevalent in the thin region of the sample. Another component is much more prevalent in the thick region of the sample. And then a third component is really emphasizes these precipitates, which are the part of this material that the researchers were really actually interested in. And again, the process data here is much, much smaller than the raw data. And so if I wanted to go and further analyze these precipitate particles, I could transfer and maybe email myself this image rather than the entire 4 gigabyte data set. So now moving on, all of the following script examples, I'm not going to go through line by line, and I only display the full script here, not so you can read it because it's way too small, but just so you can see how long or how short, in this case, the script is, 88 lines of code here. And this example, I want to show an example of scripted data acquisition. So again, because Python is integrated directly within GMS, we can use these scripts to actually acquire data as well. And the user interface in GMS currently doesn't support time-lapse imaging. This is something that is a little bit surprising to me that we don't do this, but this has never been possible, as far as I know, to do time-lapse scripting directly from the user interface. But this has always been possible using DM scripting. And now we can also acquire time-lapse data using Python scripting as well. And I don't have a nice video showing how this script works. To be honest, I don't have a good sample for this that would show something interesting happening over a period of many minutes or even hours. But if you're interested and would like this script, please contact me. You could use the questions pane in this webinar to ask me for this script or any of the scripts. I'm happy to share any of the scripts here if you ask for them specifically, or email me, and I'll show my email in a few slides later in this presentation. The next example that I want to talk about, although I don't even have a script written for this yet, but I'm excited about the possibilities for triggered data acquisition. So the current user interface in GMS really doesn't support triggering of data acquisition using some external stimulus. So for example, I might want to start a video when my sample reaches 200 degrees as I'm heating it in the microscope. And then maybe stop some specified amount of time after reaching a final temperature. And again, this has been possible using DM scripting. And so some people have done these type of triggered acquisitions. But now we can do this using Python scripting as well. So if you are more familiar with Python scripting, or Python would make it easier to integrate the other tool outside of DigitalMicrograph, then that is now a possibility. And I'm really excited about this. So if you write a script like this, please let me know. Yeah, I'm really interested in that possibility. The next example or set of examples that I want to show are all about live processing and visualization while sitting at the microscope. We often need to detect dynamics during observation at the microscope in order to make good decisions about what to do next. This is especially true for in situ experiments, But sometimes it's difficult to look at the raw data and make good decisions just based on looking at that raw data. There might be a lot of noise or just too much detail in a large field of view. There might be subtle changes, or there might just be patterns that are stretched over a long period of time, like is the case in this data set here, as I'll play the video. But processing can transform the data in a way that makes those patterns and trends and anomalies more obvious. So in this video, we saw lattice planes that are disappearing from this nanoparticle, this ruthenium nanoparticle. But I'm going to produce what I call a chymograph, and that takes some measurement and plots it over time. So here I'm going to measure a line profile along this direction with a width that's indicated here by this blue box. And that width is defined in my Python script. But here I'm showing a video of me actually running this script. So I've created my ROI. Now I start my acquisition, or sorry, start my Python script, and then start playing this data back. This is data that was already collected, but I could just as easily have used this script with a live display of data during acquisition. But we can see here I'm getting a profile every time that the data display is updated here. So whether this is data as I'm acquiring the data or as I'm playing it back, anytime that this image is updated, I'll get a new profile that's being plotted here. And from the result here, I can see not only is the movement of this lattice plane quantized, it moves rapidly at a specific time, not gradually, but also, and this was a bit surprising to me, it's relatively uniform, the frequency at which this happens. And this is something that I never noticed, even after watching this video many, many times. But it's very easy to see after processing the data. The next couple of examples, I want to show a different kind of profile. So not a linear profile, but a radial profile. And this is useful for diffraction patterns or diffractograms. And because of time, I don't have time to really explain this in detail. But I'll just say that I take a radial maximum and subtract a radial average to produce this light blue radial profile. And then I can plot this over time, and we can start to see even very subtle changes in the diffraction pattern as a function of time. And I'm running out of time here, so I'm not going to explain that particular experiment. I want to go on to this one, where this is actually an example of me running one of these Python scripts while acquiring the data. So I've just clicked the record button to start an in situ video recording using our K3IS camera. And I'm again recording a nanoparticle sample as I heat and cool the sample. And this is tin, and it actually melts and recrystallizes as I heat and cool the sample repeatedly. And we can see from this profile that's being plotted over time, I can see exactly when the crystal, when the nanoparticles melted and recrystallized and melted and recrystallized over and over again. And this makes it very easy to follow the dynamics of what happened in my experiment. And again, this is processed live. I'm not processing all of the data. The camera is very fast. It's producing a huge amount of data. But every second or so, I get a display from the live view and process that and put it into my result image. So the last example that I want to show is one of analysis at the microscope. And I just talked about processing data, so I want to explain what I mean by processing and analysis and how I see these differently. So I think processing transforms data in a way that enhances desired signals while reducing unwanted data. But analysis goes beyond that and reduces a large volume of data to just a few quantitative values that can then be used to draw scientific conclusions. So in this example, when we play back this video, I have some dendrite growth. This data was collected at Northwestern University using a K3IS camera. This entire video, by the way, was only 1 second of data, which is pretty cool. So we could observe the dendrite growth occurring in a single second, and with quite a low dose rate as well, which is what we were going for with this data set. But okay, so now I have a pretty video, and it does look very nice. But to draw any sort of scientific conclusion, I probably need to get some type of quantitative measurement of that data. So that's what I want to do with a Python code. And so I wrote one. And what I wanted at the end is the length and the area of my dendrite as a function of time. So a plot like this. And so I first filtered my images, filtered each frame, and then thresholded each frame, and then performed several morphological image operations to produce these binary or really quasi-binary frames. And that's the hard part of this entire code. After that, once I have something that's binary, it's very easy to measure that using functions that are in the scikit image package for Python. And then once I can measure one frame, it's very easy to measure every frame in the video and produce a nice plot like this one. And so now I've gone from my original data video to a plot of the dendrite length and area over time, what I wanted. And I probably wrote this script in about a week, not spending all my time on it, but a fair bit of time over a week, actually for an abstract for a conference, which hopefully I will still have a chance to present this summer. We'll see. But again, I'm trying to explain, and with examples for each of these, how we can use Python in GMS and how that is really valuable. And particularly, I'm thinking about with in situ experiments in mind, though I'm sure many of you will have very different applications. But there are a lot of possibilities for Python and GMS. So how do we actually do this? I want to get back a little bit to that right here at the end. Python can now be installed in all GMS versions 3.40 and higher. And if you want detailed instructions for how to install GMS, and including how to install Python, and even how to get started with your first sort of hello world type script in Python and GMS, you can watch the video that I have a link to here and also a QR code. And that's a video we have on YouTube right now. So you can go watch that and learn how to get started. There's also a lot of resources available in the GMS help that's built into every copy of GMS. And it really has a lot of information, including here I'm showing a number of example scripts And so there's a lot of possibilities there for you to go in, take one of those examples, run it, and try to tweak it for your own use. There's also a full reference of all the DM-specific commands that we have for Python scripting. And so you can see a full reference of all those commands is in the help. Finally, we're really looking for collaborators. We want to help researchers around the world to get started using Python in GMS to address real challenges that you have. And so if you have Python scripts or packages that you wrote and already use on TEM or STEM data, or you have ideas for simple and useful scripts for GMS that you wish existed, or you have experiments or data that you think would benefit from the scripts that I've even presented here today, please feel free to contact us, contact me via email, or you can use the webinar questions pane today and let us know what your interest is and how you can help us to help you. And finally, I definitely want to acknowledge the researchers at Northwestern University who have worked with us quite extensively over the past year and helped us to collect a lot of the data that you've seen in this presentation. And then also to just mention briefly that we'll have another webinar in this series on linear least squares fitting, and that will be next month, May 19th. So with that, please feel free to continue to submit questions, and we'll try to answer a couple of those, I think, here right now live. And then if we have questions that I don't get to here today, I'll try to email you within the next week or two with answers to your questions. So thank you.
Thank you, Ben. That was a good presentation, and there are, not surprisingly, quite a few questions. The primary theme of the questions are around getting started, the configuration of Python, installing different libraries, the version numbers that are needed, things that work together. So maybe you could spend just a bit more time making sure everybody sees where the additional resources are.
Yeah.
Thanks for going back to that slide, as well as pointing out specifically in the help where the details are located. And,
Yeah.
and then also if you have experience with some of the trial and error you've done to get the environment working, that could be helpful.
Okay. Yeah. Yeah, so the first thing I would say is, I know this was quite late in my presentation that I showed this, but there is this nice video that shows, goes through the process step by step of installing GMS fresh and installing GMS with Python. So it does specifically show that and shows you how to open the script editor and how to run your first Python script. Just a really simple, print statement, hello world type script. So you can go to this video on YouTube and watch that. That's a really nice resource that's new. So that's just been posted a couple weeks ago. But then also there is a lot of information in the help in GMS. So if you go up to the menu bar in GMS, go to help and then search and contents, you'll see this entire section in the help on Python. So if you have Python installed in GMS, you should see this section in the help for Python. And it has sections on installation, configuration, how to install additional packages, and then also how to get started running scripts. It does have a lot of information in here on how to get started. So I would definitely recommend going there. And then if you still have questions, or if you have a specific question, you can direct that to me, and I'll either answer it or pass it off to someone more expert than myself who can help you. Or additionally, and I guess I didn't put this in the presentation, I think I meant to, that you can also use Stack Overflow, the website Stack Overflow. There has been a lot of use of Stack Overflow for DM scripting in the past. So if you tag your post on Stack Overflow as DM scripting, and then also tag it as Python, just use those two tags, and that will help us to know how to help you. And there are individuals who regularly help people out on Stack Overflow. So if you have a specific question that's not addressed in the help, then I would go there. But there is a lot of information in this help, and this reference at the bottom has every GMS specific command as well.
All right, thanks, Ben. And then just to clarify, because questions continue to come in, some of which are related to the GMS version, which is needed to do the Python scripting.
Yeah.
Could you comment on that?
Yeah. So definitely you need a version 3.40 and higher. I'm also aware that recently the free version of GMS had something very wrong with Python in that version. So if you recently downloaded the free version of GMS in the past month or so, and not in the past few days, I would recommend going back and reinstalling with the very latest version you can get from our website, because there was something wrong, and to be honest, don't know what it is. I didn't use that myself, but there was something wrong with the free version of GMS that we had on our website, that Python wasn't working properly. But in the very latest free version on our website, that should definitely work. And in general, anything 3.4.0 and higher it should be possible to install Python. And again, to know how to do that, watch this video or look in the help file.
There have been a number of questions, Ben, related to using Python with eels data. No specific examples in this presentation, but can you comment on using
Right. Yeah. So actually, let me go back to this example here. So this example where I'm using Python for 40 STEM, I actually had to modify this script. The original script here was in the help files for GMS that I was just talking about, where we have a number of examples. And this is in the help file as an example for eels. So using Python to do non-negative matrix factorization of an eel spectrum image. So that is an example that's already in the help about using Python for eel spectrum images. Yeah, certainly you can use Python to analyze eels data within GMS. Yeah.
Okay, and then lastly, as we're wrapping up, can you talk about the possibility of combining GMS scripting with Python scripting.
Yeah.
Presumably not all functions that are available within GMS have a Python interface. So how would somebody handle that situation where they want to do something not available in the Python interface yet?
Yeah, that's right. Yeah, so that's a really good point. You know, Python scripting now enables us to do a huge amount of different processing and analyses, but interacting with the software and with the hardware, we don't have as many Python commands as we do DM script commands. So there are things that one can do to interact with our software and with our hardware using DM script that you can't yet do with Python script. So what we've added to the Python scripting interface is the ability to run a DM script from within the Python script. And if I go back to the help, yeah, I didn't show that here today, really because of time, because I already had probably too much that I tried to present today. But if I go back here, there's a whole section in the help files and the example scripts of what we're calling hybrid scripts, where you can either call a DM script from your Python or call a Python script from a DM script. And so that greatly expands the possibilities for scripting so that you can take full advantage of all the hardware and software interface that's available through DM script, and also take advantage of all the analysis and processing and powerful tools within Python scripting.
All right, several people then have asked for your email address, so if you could just move to the slide that shows your email address, then I'll make one clarifying remark. We had one of our colleagues was kind enough to provide version information here in the question stream. So for those who have downloaded GMS 3.4.1 recently, the installer that you need that has the working version of Python is GMS Free Analysis 2. If you have GMS Free Analysis, you should update the newer version, the Free Analysis 2. And then in terms of specific GMS versions, if you have GMS 3.4.0, you need version 2808, 2808 or later. And with GMS 3.4.1, you need version 2938 or later. And with that, we'll conclude. Thank you, everyone, for joining us for this webinar series. Please continue to reach out to us. We'll respond to every question that was asked, and we appreciate your support. Have a good day.